Right. Greetings to you all. Welcome to EduBlush Visual Academy. I'm going to be looking at um functions and graphs, grade 12, functions and graphs, specifically looking at the inverse of a function graphically. I looked at the inverse of a function algebraically in the previous lessons. Now I'm looking at the inverse of a function graphically. Okay, right, graphically. Right, now let me take you to the board so that I can quickly start with this lesson. I've done two, lesson 5 and lesson 6, which was basic preparation of this. So go through lesson 5 and lesson 6 before you come to lesson 7, then you see the continuation. Okay, right. Now let's take to the board, and I'm going to start with some illustrations that are very, very key to this study. This is a section. That's a very interesting section. I hope and believe that you guys will enjoy it. This is under what we call functions and graphs. So let's look at functions and graphs. Functions and graphs. Sorry, functions and their graphs. Okay, right. I'm going to be focusing on inverse. We said inverse means the reverse process, inverse of a function, deducing the inverse of a function graphically. Okay, deducing the inverse of a function graphically. Okay, deducing the inverse of a function graphically. I'm going to start with an illustration. Examiners will require you guys to come up with the inverse of a function, either algebraically or graphically. Right, I'm going to start with an illustration to this. Let's look at an illustration. Let's look at how this illustration is going to help me. I'm going to give you an illustration, then we are going to generalize this together. Okay, right. I want us to draw the graph of f of x. Draw f of x, which is equal to 2 to the power of what? X, which is basically an exponential graph. Okay, right, let's look at this graph. I'm going to come up with a table of values. Then I'll build my argument from this table of values. Then we generalize. After generalizing, then we come up with a path that we can always resort to when we are deducing the inverse of a function graphically. Okay, so we're going to come up with a quick path that is going to help us to come up with the inverse of a function. Let's look at this. Let's look at this. This is, say, 3, 2, 1, 0, -1, -2, -3. This is x, this is y. Okay, now if my function is 2 to the power of x and I substitute the value -3, so if I put -3 there where there is x in the function, 2 to the power of x, this will be 1 over 8, okay, which is 0.125. Okay, if I put that, that will be a quarter, which can also be written as 0.25. That will be a half, which is basically 0.5. Then put 0, that would be 1, that would be 2, that would be a 4, and that would be an 8. Okay, right. I'm also going to draw on the same axis. I'm going to say, right, if this is my function, I'm going to draw this. I'm going to put it on my Cartesian plane. Right, allow me to draw a Cartesian plane there, where I'm going to draw this. right? I'm going to say starting from -3. So this is -3, -2, -1. This side it will be a 1, that will be a 2, and that will be a 3, something of this sort. Okay, right. This is your y-axis. Label it y-axis and x-axis. Then from that going upwards, I can say this is um, 1, let me say 2, 4, 6, 8 for argument's sake. So that I can say 2, 4, 6. Okay, there you go. Label it 2, 4, 6, 8, something like that. Okay, if I'm to draw, the first one is 0.125, 0.125 somewhere there, right? A quarter, 0.25 somewhere there, then -1, then that's 0.5 somewhere there, right? Then from there it passes through 0 and 1, 0 and 1, then 1 and 2, 1 and 2 is somewhere there, then 2 and 4, 2, 4, then 3 and 8, 3 and 8. That's your exponential function, which is increasing. That's my exponential function, which is basically what? Increasing. Okay, this is the graph f, which is equal to what? That's your graph f equal to 2 to the power of what? X. Right. Now I'm going to come up with the table of values of the inverse. Remember, I said the inverse is basically the reverse process. So if it's the reverse process, this is how I'm going to manage this. Right. Now I've got the first coordinates there. Look at this. 1, 2, 3, 4, 5, 6. Look at this. Right. This is my coordinates. This is x, this is y. Now, what am I going to do this time? Look at this. Remember, we said this is the inverse. Now, if it's the inverse, it means we are supposed to interchange the variable. That which is y becomes x, that is which is x becomes what? Y. So in this case, my first x value will be 1 over 8 and my y value will be -3. I'm just interchanging. That which was y becomes x, that which is x becomes y. As simple as that. Okay, that which is x becomes y. So that would be -1, 0, 1, 2, 3. Then this side it will be what? -1.5. This is now 0 and 1. Sorry about that. Then this is what? 1. Then that will be a 2. That will be a 4, and that will be an 8. Along what? The x, along the x-axis, something like that. Okay, right. Now I'm going to start with my plotting. Right. If I'm to plot these coordinates now, the first one is negative 1 over 8. So that is -1 over 8, and um, -1 over 8 and -3 on the y-axis. So I'll come and say -1, -2, -3. So negative an eighth somewhere there. Then negative a quarter and -2, negative a quarter and -2 somewhere there. Then -1.5, -1.5. There you go. Then the next one will be what? Negative +1 and 0. +1 and 0 is somewhere there. Then I'm also going to come to 2 and 1. 2 and 1 is somewhere there. 2 and 1 somewhere there. Then 3, 2 and 1, 4. Okay, along the x-axis, I'm now at 4 and what? And 3, 4 and 3, 4 and 3 somewhere there. Right, then the next one will be what? 8. Allow me to extend 8 and this was 4 and 2. 4 and 2 is somewhere there. Then 8, 8. So 4 is there. 8, 8 and 3. 8 and 3 somewhere there. Okay, right. If I'm to join these coordinates, you see that you come up with something like this, something like this. There you go. I'm just joining my points. Okay, right. Now, there you go. Those are your two graphs now drawn on the same set of axes. Right. With that, I'm going to come up with my generalization. Right. If you look at this, let me come to labeling. This is going to be the inverse graph. Okay, this is the original function f. The inverse graph is the logarithmic function. Remember, the strong bond between an exponential function and a logarithmic function. This is the inverse of an exponential, which is logarithm. So you can see that this is your logarithmic graph coming from the, which is the inverse of the exponential. Okay. All right. Now, let me come to a generalization out of this. So if I am given, say, given that f of x is equal to something like this. This is negative 3, 1 over 8. I'm just stating it as coordinates, negative 2 and a quarter, then negative 1 and a half, then 0 and 1, then 2 and 4, 3 and 8. This is your function given. Right. Now, f inverse is going to be equal to what? 1 over 8. What am I doing? I'm now interchanging positions. This becomes a quarter and negative 2. Then this becomes a half and negative 1. There you go, which is 1 and 0, 4 and 2, 8 and 3, something like that. That would be the inverse function. Okay, now what are we observing on these coordinates? Now, what you are observing on the coordinates is, for me to get the inverse function, I'm just simply going to interchange variables. Now, if I take you to grade 9, which rule is that? I'm going to say which rule of transformation is responsible of interchanging variable, right? Now, the rule was in grade 8, it says xy is being mapped onto yx. And this rule is after what we called a reflection. This is now the type of transformation which is responsible of doing that reflection of the function or reflection of the coordinates along the line y equal to x. Right. Now, this is an important rule now. Whenever you are asked to come up or to deduce the inverse of a drawn graph, you are supposed to reflect the drawn graph along the line y equal to x. Does it mean that every time when I'm trying to come up with the inverse of a function, I have to go through the whole process of the table? No, the shortest and the fastest way. That's why at times you realize that examiners will come and give you 1 mark to get this inverse. Now, how do I manage that? I'm only going to use the rule, which says for me to determine the inverse of a graph, the inverse of a drawn graph, I'm going to reflect the drawn graph along the line y equal to x. Where is the line y equal to x coming from? From the illustration that we looked at in the in my previous illustrations there. Now look at this. So I'm going to conclude in terms of conclusion. I'm going to say this is an important conclusion. To determine the inverse of a drawn graph, one should reflect the drawn graph along the line y equal to x. Very, 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 very important. This is very, very, very important conclusion. I'm going to be using it. Okay, let's look at an example. Let's look at a quick example. Let's draw as close as possible to an exam type question. Okay, right. Example number one. Example one, given f of x drawn below. Okay, I've got something like this. I've got something like that. Okay, there you go. Then there you go. That is one. Okay, right. Now, the first question there says draw the inverse of f, on the same set of x's above. Right. Right. Secondly, determine the domain and range of f. Right. C, determine the domain and range of f inverse. Then D, what conclusion can you deduce from answers to B and C? Right. Now let's look at this. Let's solve this together. Let's solve together. This question says, given f of x, interpret what f of x is. F of x is an exponential function, which is what? Increasing. That's an increasing exponential function. Now the question says, draw the inverse of f on the same set of axes. Okay. Now, if I want to come up with an inverse, remember, we concluded that for us to come up with the inverse of a function, I'm supposed, if it's a drawn graph, I'm supposed to reflect the drawn graph along the line y equal to x. So I'm going to go and say, let me insert the line y equal to what? X. That's my line of reflection. In other words, right, that's my line of reflection. In other words, you are supposed to, sorry, this line passes through the origin. Sorry about my slate there. It moved a little bit. Allow me to draw another one. Sorry about that. Sorry about that. Okay. Okay, right. Okay, allow me to draw another line so that you guys are not in a bit of a mix. Right. You now, if I am to draw my line of reflection like that, okay, I want us to take a mirror, put a mirror along that dotted line, right? The one which passes through the origin, okay? The one which passes through the origin. Put your mirror there. Now, if I am to put my mirror there, if I am to put my mirror on that line, on this continuous line, let me just put a continuous line. Sorry about that. There was a shift in my arrangement there. Okay, right. This is the line that I'm talking about, which is y equal to x. Just ignore this one. Okay, ignore this one, ignore it. Okay, fine. If you look at this, if I insert a mirror there, I'm reflecting f along the line y equal to x to get the inverse. Now, I'm going to say if I insert that, then it means whatever coordinate is on f, its coordinate, whatever coordinate is on f, whatever coordinate is on f, its entries when it's reflected along the line y equal to x, it's supposed to interchange. That which was x becomes y, that which was y becomes x. So in this case, I'm going to say this is now what? 1 and 0. That becomes 1 and what? 0. Right. Now, if I insert my line of reflection there, you will see that this is going to be something like this. If you insert that, you put a mirror, you will see that the inverse is going to come out like this. That will be the image, okay, which is your F inverse. Okay, that is going to be your F inverse, which is the reflection of F along the what? The line y equal to 0. If F is an exponential like that, it means F inverse is the logarithm. Right, look at that relationship. F of x is an increasing exponential function. F inverse is an increasing logarithmic function, which is its inverse. Okay, right. Let's come to the next question. Determine the domain and range of f. Domain, what is going to be my domain? The domain to this is going to be what? F. Look at f. It starts from where? From negative infinity. Where does it end? At positive infinity. So it means x is an element of all real numbers. Take note, all exponential functions, their domain is x element of all real numbers, um, unless or otherwise there are other restrictions that comes with it. But under normal circumstances, in the domain of any exponential function is from negative infinity to positive infinity. What about its range? Let's look at its range. What about range? Range of this function, the function starts right after, it starts right after what? The x-axis, going towards positive infinity. You can all see that the range of this becomes y greater than what? 0. Okay, let's come to the next one. Determine the domain and range of F inverse. F inverse, I'm now looking at the inverse. What is its domain? The domain, this graph starts after the x-axis, after the line x equal to 0, going towards where? Positive infinity. So it means the domain to this graph is what? X greater than what? 0. What about its range? The range to this graph, the range to this graph, I'm going to say where does it start along the y-axis and where does it end along the y-axis? It starts from negative infinity to positive infinity. So it means the range of this becomes y, element of all real numbers. Okay, what conclusion can you deduce from the answers to to your B and C? Look at this. That which was the restriction of the domain, where we were saying x element of all real numbers, it becomes the restriction of the range of the inverse. That which was the restriction on the range of f is now the restriction of the domain of the inverse. Okay, very, very important. The restrictions the restriction of the domain of f becomes the restriction of the range of f inverse, and also the restriction of the range of f is the restriction of the domain of f inverse. Loosely speaking, we can say that which was the domain becomes the range of f inverse. That which was the range of f becomes the domain of f inverse. Okay, so that's an important discovery. It's an important notion that you are supposed to carry with going forward. That's very important. I would like to emphasize that. Please, that is key to your study. Okay, right. Let's just look at an illustration. Let me just do an illustration on what I was looking at so that you guys can apply this. Right. Now, I said, if I'm given a function, look at this. If I'm given a function, then this function of mine is something like that. And this is where 1 is. Right. If that is the case, this is what your f of x is. Right. And I'm trying to get the inverse of this graphically. We said for you to come up with the inverse graphically, all you do is you reflect whatever function is given along the line y equal to what? X. Whenever you find yourself reflecting along the line y equal to x, know that you are getting the inverse of that drawn graph. So if I reflect this curve, put a mirror along this line, facing where f is, you realize that you are going to check in the mirror. Whatever image is going to come out, it is that of the inverse. So if this was 0 and 1, that becomes 1 and 0. So it means that curve which is facing upward, if you check it in the mirror, it will be coming out like this. That's what we are talking about. So this is now f inverse. Yes, look at this, look at this, look at this. Try it, attempt it, use your mirror. If I've got something like this as a curve, this curve is your f, and they want you to draw f inverse. You're going to draw the line y equal to what? X, something like that. Now, after drawing the line y equal to x, I'm saying if this is 2, then 0, 2, that coordinate, when it's reflected along that line, it becomes 2 and 0, something like that. But the curve is facing the mirror. If I put my image, or if I put my reflection line there, or if I put my mirror there facing the curve, and you check the image is going to come out like this. Check inside the mirror, you see that is how f inverse looks like. That's exactly where the concept is. Now, if I'm just to expound on this, look at the first graph, first illustration, call it A. What is the domain of the first f f of x there? The domain of that, it is what? X greater than what? 0. Because you can see greater or equal to 0. You can see that it starts at x equal to 0 going towards positive infinity. Right. What is going to be its range? Range, it is going to be y greater than or equal to 1. It starts at 1 going towards positive infinity, something like that. But now come, this was f. What about f inverse? On my F inverse, it is basically the same thing. You are going to say domain, you are going to say range, right? If you want, you can go and trace it direct and say, okay, this is my graph that I'm going to analyze, which is your F inverse. Right. Now, how am I going to do that? I'm going to say, where does it start? It starts now at 1 along the x-axis and it ends at positive infinity. So it means the domain of this one, it is now x greater than what? 1. What about range? It starts at x equal to 0, which is the x-axis, going towards what? Positive infinity, which is now what? X which is now y greater or equal to what? 0. You can see that which was the restriction on the domain is now the restriction on the range. That which was the restriction on the range is now the restriction on the what? On the domain, okay, of F inverse. This is your F inverse. Now, the same thing goes if you come and now analyze the other graph. Look at this graph. This is the y-axis, this is the x-axis. What is the domain of this first graph? You can see that the domain of f, this is your f, domain of f is going to be what? X greater than what? Or equal to 0. What is going to be the range? The range, it is y greater or equal to 2. So it means if I'm to come and look for the domain and the range of the inverse, I'm simply going to come and say, look at this, look at this. That which was the domain there becomes the restriction on the range. So this is just y greater or equal to 0. Without even looking at the inverse, so someone should be able to pick that. Okay, right. Then this will be x greater or equal to what? 2. There you go. So after getting the domain and range of f, you should be able to come up with the domain and range of f inverse from the domain and range of f. Okay, right. Now let me look at another example. Let me look at example number 2. Right. I am given here f of x drawn below, right? F of x drawn below. Look at this, right? I'm going to say I've got a graph of this sort. There you go. Then right, this is your f and that coordinate is 1. Then they are saying determine the draw the inverse of this function. Draw the inverse of the above function on the same set of x's. Right, how do I do that? Very simple. For me to get the inverse of a drawn graph, I'm going to start by inserting the line y equal to what? X. Okay, after inserting the line y equal to x, this is now your line of reflection. If I reflect this and there's a coordinate like this one, it's 1. If there's another one, say 2 and 5, and I'm reflecting along this line, it means if I put my mirror line there, this graph is going to be thrown up. This side is now 1 there. Okay, there you go. This is a logarithmic graph, and you can see that its asymptote is vertical. The inverse is exponential, which is also what with its asymptote, which is horizontal. So it means I'm going to insert my reflection. If you put a line of reflection there and you put a mirror, you see that the image is going to come out like this. This is f inverse. Look at that. The inverse of a logarithmic graph, which is increasing, is exponential, which is increasing. There is another point, which is 2 and 4. When you 2 and 5, it becomes 5. 2 and That was 2 and 5. Okay, right. If I reflect this, it means this coordinate will be somewhere there, and that coordinate will be 5 and 2. Okay, that's interchanging their positions. Okay, right. That is how you draw the inverse of a graph. That's how you draw the inverse of a graph. Right. Allow me to do another set of examples there. This is something that you just have to drill in. This is something that you have to stretch your imagination for you to master it. You're supposed to be able to stretch your imagination and try to imagine the image that is going to come out when you reflect that function. Okay, let me just look at another example to this. Right, let's look at an example. Okay, let's look at this example. Given that f of x is equal to log x base half, something like that. So I am given something like this. There you go. There you go. Y x. So this is going to be something like this. It's drawn and it's given. Right. This is f. Okay. The first question says draw the graph of f inverse on the same set of axes. Okay. B, determine the domain and range of f and f inverse. Then, okay, determine the domain and range of f inverse. Okay, right. Now, C is f inverse a function or not. Justify your answer. Right, now let's look at this. Given that f of x is equal to log x base half, you can see that that's a logarithmic graph which is generally decreasing. Draw the graph of f inverse on the same set of axes. The graph of f inverse, I'm going to get it by reflecting. Remember, f inverse, you reflect along the line y equal to what? X. So GR12, the first thing that we are supposed to think of is inserting that line of reflection. Okay, then from there, I'm now reflecting. Right, if I am to reflect this line, just looking at this upper piece of the function, if you look at this upper piece of the function and I want to reflect it, it means it's going to come out like this. Good. Right. What about this outer one, which is going down, this one? What about this remaining piece? How is it going to come out like? Right. That piece, if I reflect it, it's going to come out like this. Right. So it means the dotted line becomes F inverse. The dotted line is F inverse. You can see that the line y equal to x, F inverse, and F, they are all meeting at the line of reflection there. That's very, 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 very important, right? If this is 1, that will also be 1, something like that. That is the graph of f and its inverse drawn on the same set of axes. Now, determine the domain and range of f, right? I'll come and say domain and range of my f of x, right? What is going to be the domain of f of x? Domain of f of x, we can see that this is x greater than what? 0. That is the domain. You can see that it starts at x equal to 0 and it goes to positive infinity. Okay, this goes to positive infinity. So it's from 0 to positive infinity, which is just x greater than what? 0. But not touching that x equal to 0 line or the y-axis because it's an asymptote. What about range? It starts from negative infinity to positive infinity. So it means your range is y element of all real numbers. Okay, what about f inverse? I am not supposed to worry about f inverse because there is a relationship between the domain and range of f and the domain and range of f inverse. So I'll come and just say domain, I'll say range this side. That restriction, which was for the domain, becomes the restriction for range on f inverse. That which was the restriction for range on f becomes the restriction for the domain of f inverse, that kind of a thing. So it's how you deduce the domain and range. Now the last question is f a function, f inverse a function or not. If you look at the dotted line, this is going to be what? A function. What type of a function is that? It's a one-to-one function. It passes both the vertical line test and the horizontal line test. So you can say it is a one-to-one function. Reason, one element of the domain is associated with one element of range. Okay, good. That's how you do that. Okay, right. Lastly, the last example there, right? The last example there, given the graph drawn, right? I've got a graph like this. I've got a graph like that. Okay, I've got a graph like this. This is a function that is drawn, passes through the origin. There you go, there you go, there you go. Now the question is, right, A, draw the graph of f inverse on the same set of axes. Okay, right. Now if I'm to draw that graph, look at this, I'm going to say we're trying to come up with the inverse here, and from our previous analysis we said whenever you're determining the inverse, you have to insert what? The first thing graphically is to insert the line y equal to what? X. Remember, the line y equal to x is the line which passes through 1, 1, 2, 2, 3, 3, 4, 4, on and on, minus 1, and so forth. Right. So if I am to reflect, it means if I put a mirror there, you can see that the image is going to come out like this. That is that part. Okay, right. What about this one which goes this side? If you look at the one which goes that side, when it's reflected, it will go out like this. Good. Right. That will be your f inverse. Okay, so the first one is f of x. The dotted one is actually what? Your f inverse. This one will be the f inverse. That one, that will be the f inverse. Okay, now if you look at this, My f of x was a many-to-one function. What type of a function is f? B. C. What type of a function is f inverse a function or not? Justify your answer. Okay, right. What type of a function is f? F, the original function, this one, f of x, the cup-shaped parabola, it is a what? A many to one function. That is a many to one function. One element of the many elements of the domain is associated with one element of the what? Of the range. Is f inverse a function or not? Now, if you look at f inverse, it fails the vertical line test. If I insert the vertical line, it fails, meaning to say one element of the domain is now associated with two elements of the range. Okay, so it means f inverse is not a function. One element of the domain, one element of the domain is mapped or associated, mapped onto many elements of the range. So it's not a function. Okay, right. I think I managed to take your depth a little bit further down. I'm going to give you work that is on this aspect. Please, let's meet in the next class. In the next class, I'm going to be analyzing many to one function and their inverses, a very common technique in an exam where we are supposed to be restricting the domain of a many to one function so that its inverse becomes a what? A function. What we should appreciate is the inverse of a one-to-one function is one-to-one, and the inverse of a many-to-one function is not a function. Okay, that is what example number 3 and number 4 was all about. It was just to show us that the inverse of a one-to-one is one-to-one, and the inverse of a many-to-one function is not a function. Okay, right. So please, let's just look at examples. I'm just going to give you one or two problems before I close this class so that at least you can exercise and try to come up with the domain and range of these functions. Then I'm going to also post more on EduBlush. Thank you so much for joining us. Hope and pray you've mastered, you've picked one or two things from our you've picked one or two things from this presentation that is going to help you solve different problems. Just to give you just questions, I'll urge you to go to EduBlush. Then you are going to get more and more questions that will help you understand, apply this concept so that you can clearly see that you've understood whatever we are going through. Okay, thank you for your time. Um, Stay with us, keep following, invite your friends, send our videos to your friends, help as many grade 12 as possible. If you encounter challenges, call us. We can always come and assist you. Thank you.